Okay, well, thank you for attending. A question for you guys. What do you prefer, Spanish, English, or Portuguese? I need one more day. No, okay, so English is good?
Yeah.
Okay. So today I'm going to be doing SQL Tuning 101. So here I assume we have a lot of DBAs, right? DBAs. What about developers? Some? Management? No management. Good. I introduced myself this morning, but not necessarily you were here, so I'm going to go very quickly. Who am I? My name is Carlos Sierra. I used to work for Oracle. I worked for Oracle for many years. And before Oracle, I worked for Unisys, also way too many years. And before that, I did some Apple development very early. And I am the author of some tools like SQL T Explain, SQL Health Check, EDB360, and some others. Trace Analyzer is another one I don't mention often. I also did something for SQL Profiler. Who uses SQL Profiler? So you guys, PL SQL Profiler, sorry, PL SQL Profiler. Yeah, I developed also something for that. I also developed some scripts to collect statistics for e-business, for SQL, and for PeopleSoft. Anyway, I do a little bit of everything. I am an Oracle Ace Director. I also lead a small team, Orapips. I work for Enkitech, and you have heard the name Enkitech a lot today. Enkitech is now part of Accenture. Enkitech used to be a small company, and it was acquired by Accenture. And this is my motto, life is good. Regarding the agenda for these 45 minutes, we have some motivation, why SQL Tuning is important, why we have to do that. Some methodology, diagnostic collection, root cause analysis, remediation, and some important topics, like understanding the execution plan, the CBO, and plan stability, and some free tools. Well, motivation, the first one that I have here is one SQL can actually bring down an entire system. I have seen that in the past. One SQL that is consuming a lot of resources, you execute the same SQL concurrently many times, and your system degrades. This is not exactly the case, but we can see here there is one SQL that is consuming 25% of the resources overall, over a period of time. So here we're saying for the past 5 working days, one SQL is taking 25% of the resources. That is a lot. Imagine you have 2 or 3 like this, and pretty much all your resources are depleted. Okay, SQL Tuning. Who likes SQL Tuning? Some of you guys. Okay, one more hands. I always say SQL Tuning is like sushi. You either love it or you hate it. But there is no in between. No in between with SQL Tuning. Why? Because it's complex. You try to do SQL Tuning, it's going to be a complicated task. In part, it's science. It means it's an exact science. In the other part, it's kind of an art. Who is responsible for SQL Tuning? Is it the DBA? Is it the application developer? Who is responsible in your cases? Who is responsible for SQL Tuning?
Everybody.
No one, right? Yes, SQL Tuning is something that we always try to have someone else do it. We're trying to avoid SQL Tuning. It's quite common. When I think methodology, I usually think on 3 steps. The first one is collection. The second one is root cause analysis. And the third one is remediation. But you notice here we have 4. Because there is one that we usually forget, which is good practices. So let's start with that one, good practices for SQL Tuning. We usually forget about this, but I would say this is the most important one. I have learned over time, the cost-based optimizer is like my mother-in-law. If you are nice to her, she may be nice to you. But you have to start being nice. So if you are nice to the CBO may be nice to you. Okay, so just keep that in mind. When you have a healthy environment, you need less SQL tuning. That is true. It's a win-win. I mean, if you maintain your environment healthy, you need less of a SQL tuning. Everyone wins, except consultants like myself. Why? Because if your environment is all messed up, we have a lot of work to do, right? If your environment is clean, we have less work to do. So if for us, it's like, okay, one of the things that we do with SQL tuning, we look at parameters. When we see a lot of parameters, we say, okay, there's a good opportunity, there is a lot of work to be done here. The more parameters we see, the more work we have to do, okay, to fix it. So let's talk about some good practices. What is good? I cannot say best practices because that doesn't exist. I mean, best practices for something is not real. Good practices. The first one, start with a solid database release. Today, what is a good solid database release? Anyone? 11.204. Yes, 11.204. That is, in my opinion, right now, that is the one solid database release as of today. Of course, that will change soon. As soon as we have 12.2, that may change. But for now, it's 11.204. So that means if you are on 11.202, 11.203, 11.1, some clients are in 11.1, right? Some are in 10.2, even some that are on 10.1. Those are releases that you want to actually just go to 11.204 and you are immediately on a better shape for SQL tuning. Okay, just keep that in mind. Second advice, you don't want to be messing with the CBO. You want to keep the CBO as clean as possible. So I suggest you consider resetting CBO parameters to the defaults. Just use the defaults. There are some cases when you have to deviate from the default, but for the most part, you want to be on the default values for the CBO. Another one, gather statistics. There is this idea that if you don't gather statistics, your execution plan doesn't change. Have you heard that before? That if you don't gather stats, the plan doesn't change? Well, that is a lie. That is not true. Even if you don't gather stats, your plan may change. Okay? I could explain why and go into the reason, but for now, just understand that if you don't gather stats, your execution plan may still change. So it's better to have statistics collected the way they are supposed to be and keep them updated. It doesn't mean gather stats every day or every 5 minutes. No, just keep them reasonable, which are good enough. That automatic job is pretty good. The last one that I have here is write some sort of reasonable SQL. When we look at the SQL, and the SQL is many pages long, well, it's going to be very hard for the optimizer to generate an optimal plan. In most cases, the longest the SQL it is, the more suboptimal it's going to end up. Does it make sense? A smaller SQL is easier for the optimizer to optimize. So just keep that in mind. So a partial list of parameters that we want to reset are, first one, optimizer features enabled. Who uses this parameter on a production environment? Optimizer features enabled. Couple of hands. Yeah, that's one of the parameters. When you do an upgrade and you have a regression, and you notice, I mean, if I set this parameter to the value before the upgrade, and everything works better, you may be tempted to leave this parameter. As a short term, to do it for one section, you should be fine. But if you are noticing, you're finding yourself leaving the parameter there, you try to avoid that. It's not a good practice. That always fires back. There is always consequences that you have to pay in the long term when you have that set up. Another one that is typical that we see optimizer in the index cost adjustment or index caching. Those are parameters, they were pretty common to be set up like on Oracle 8. DB5 multi-block read count. This one is not necessarily CBO parameter, but for a long time, Oracle has recommended to onset this parameter. Okay? Cursor sharing, again, it's not an optimizer parameter, but it affects how the optimizer works. Optimizer dynamic sampling, optimizer mode, and there are some others. Just keep in mind, in general, you want to keep your environment as clean as possible. The second pillar that we have is diagnostics collection. So imagine that you have some SQL tuning. In other words, you have a user that is complaining a particular process, report, transaction is taking long. What is that you collect?
AWR.
AWR?
Hash.
Not for one SQL.
Oh, hash.
Hash, Hash, you can use hash for one SQL, yes,
Yeah.
but where do you start for diagnostic collection? Well, the first step, you need to find the SQL, right? With AWR, you can find the SQL. It doesn't necessarily tell you much about the SQL, you can find the SQL. So that is the first step. Second step, you want to use the Oracle-based product tools, like what? SQL Trace, Ticket Prof. I will mention those in detail. And the third step, you want to supplement with some specialized tools. The reason is the Oracle product-based tools may not be enough, so you need more for SQL tuning. For that, you have to use these special tools that we have, and they are available. So I'm going to talk about those as well. To identify the SQL, there are many ways. One of them is Enterprise Manager. So who is using Enterprise Manager? A lot of people, right? Perfect. We can also use AWR to find that SQL. Who uses a stats pack? A stats pack here? Some hands. Good. Good.
Standard, no?
What about SQL Trace and Ticket Prof? Some of you guys are pretty familiar with that? Perfect. Perfect. What about $V dynamic views? It's also useful, right? You go through $V views and you find your SQL. What we're talking here is to find the SQL ID. Regarding Oracle-based products, what comes to your mind? I mentioned a couple, right? SQL Trace, Ticket Prof, Ash, Explain Plan 4. What did we learn about Explain Plan 4? That it lies. That it lies, but it's there. It's there, and in some cases, we can use it. What about AutoTrace? Who uses AutoTrace? Yeah. Some of you guys. Yes, all these tools are legacy. They have been around for quite some time, except the second one. The second one has been around since Oracle 10, but the others, they have been around forever and ever. What about SQL Developer? Yeah, we can use SQL Developer. It's also free, right? We like free, so we can use SQL Developer. What about DBMS Explan? Yeah, it has some kind of weird syntax, but we can use DBMS Explan. Those are the legacy product-based tools that we can use and we do use for SQL tuning. What about SQL Monitor? Some hands? Yeah, SQL Monitor is awesome. It's a really nice tool, but you have to have the tuning pack. Okay, that is the only con I would say. But besides that, that's another tool we can use for SQL tuning. Now, why do you think we have that many tools for SQL tuning? Because they are never enough. They are never enough. When we started with SQL Trace and Ticket Prof, before Ash, before SQL Monitor, before DBMS Explan, before SQL Developer, that was not enough. All these tools are basically closing the gap to what we need for SQL tuning. Okay? And even if you combine all of these together, they are not enough. So with SQL Trace, we get to see something like can you read that here? Yes? I cannot read that. Oh, okay, so with I was meaning this one here, not that one over there. Okay, with SQL Trace, you can do alter session, set, and there are several ways to turn trace on and off. The easiest one is just say alter session, set SQL Trace true. Well, you can also use this event 146. In the old days, 146, it had the values 1, 4, 8, and 12. Now it has some extra values that we can use. So once you turn trace on, you execute your transaction, turn trace off, and then where do you find your trace?
User them test.
Well, there are a couple of places. On 11G, we can go and see $diag info, and you can see where the trace, right? Before 11G, you can use user.dist. I still use user.dist because it's very convenient. But this one is deprecated for 12C. So you're moving to 12C, you need to be using $diag info. And an easy way to turn it on and find the trace and look at the trace is like this. I mean, we can turn trace on, then that is the method to turn it off. And then how do we find the file? This is just a very small script that basically allows you to read where the file is. And then with that information written on a variable here, on this variable, we can just say host ticket prof and provide the value of the bind, and very easily we can ticket prof. Does it make sense? This syntax is just a script with 4 lines, and basically that allows you to get something like this. I'm gonna show you. This is a ticket prof. We see a SQL statement there. That SQL statement is based on the sample schema, the HR sample schema. And then we have some metrics for the execution of the SQL. Here, we see in more detail, we basically we're looking at the next page of this one here. This is the first page, this is the second page. And here we see, what is this, an explain plan or an execution plan?
Execution plan.
An execution plan. One thing you need to be aware of, whenever you see on a ticket prof that says execution plan, that is not the execution plan, that is the explain plan. The execution plan, it says role source operation. Okay, just keep that in mind. If it says execution plan, it's not true. That is the explain plan. Okay? So whenever you do ticket prof and you say explain and provide the syntax for explain, then you get to see this that says execution plan, but it's not execution plan. It took me some time to realize it wasn't the execution plan. Just keep that in mind. Now, here we have a lot of information, which I mean, I'm gonna be talking about the explain plan in a moment, the execution plan, but for the time being, it's just this part of ticket prof. Let's talk about ASH. I expect everyone to be familiar with ASH. Is that right? Everyone knows what is ASH. Good. Good. Active session history. We're basically taking snapshots of the dollar session, and we keep those snapshots, and then we store into the repository every 10 of those samples. And we can find, from that information, we can find sessions which are on CPU or waiting non-idle. If the session is waiting on an idle event, it's not here. But if it is waiting on idle or CPU, it's gonna be here. It has multiple dimensions, meaning we can aggregate. We can aggregate by different ways. We can aggregate by SQL ID, by action, by module, by program, by user, you name it. We can aggregate multiple ways. It's excellent for performance analysis. So whenever you're doing some performance analysis, you want to have some kind of tool that is doing data mining on top of ASH. Requires diagnostics pack. You have to have the Oracle diagnostics pack in order to use ASH. Now, if you notice, there is a little bit of overlap. I mean, we can do analysis, SQL Tuning analysis with SQL Trace. We can do SQL Tuning analysis with ASH. So let's talk for a moment pros and cons. Pros on SQL Trace. It's precise. It's extremely precise. If you want to have the exact numbers, you use SQL Trace. It's free. SQL Trace has been around for a long, long time. You don't require a license to use Trace. Some cons, you have to re-execute the transaction. If you were not tracing, you have to go back, turn trace on, and re-execute the transaction. That's a big con. The weights that you see are per SQL, not per execution line. So the granularity for the weights is for the entire SQL. Sometimes you see a weight and you say, okay, I notice my SQL is waiting on whatever, but I don't know to which line on the execution line it belongs. So some pros for ASH is always available. We don't have to turn it on. It's always there. So the history is being created automatically. It's the multi-dimensional that I mentioned before. And we have execution line granularity. So that means we can see what happened for each line. So some cons, or one con, it requires a diagnostic pack. With that in mind, some people prefer to use SQL Trace, some people prefer to use ASH, and some of us, we use both. Okay? And it's really up to you. What do you use? Who uses both for SQL Tuning? Most of you guys. Good. Okay, explain plan 4. Look at that SQL. Well, that SQL is based on the sample schema. We have a couple of subqueries. What happens with the explain plan? Well, the actual SQL is not executed. And explain plan 4 is bind to bind picking. Therefore, since it's a blind to bind picking, what happened? I don't see any Pokemon. So explain plan is blind to bind picking. Therefore, if this command cannot see binds, and if I have binds there, the binds will basically make the explain plan different than the execution plan. And that is what Alex was saying about the explain plan may lie. Okay, just keep that in mind. So here we see a sample of what? Is this an execution plan or is this an explain plan?
Explain plan.
Explain plan. How do we know that? Well, because on the prior slide it says explain plan, right? But actually we know it's explain plan. When you see columns like rows, bytes, cost, even time they may give you the illusion that it's an execution plan, but it is not. Okay, this is an explain plan. We have the explain plan and we see some predicate information that's pretty cool, very useful. Let's talk now about auto trace. Some of you guys raise the hand and say, yeah, I use auto trace. With auto trace, we set auto trace on. We actually execute the SQL statement, and then we can see the execution plan. That is the execution plan, and we can see a subset of session statistics. Like in this case, this one also looks like the explain plan, but in this case, it is actually the execution plan. And then we see some predicate information, and we see some performance statistics for the one execution. Yeah, unfortunately, it only gives you a small subset of those statistics, but it's better than nothing. So I would say auto trace is good. Auto trace has been around for a long, long time. We have SQL developer, and if you notice here on this SQL developer screenshot, we can basically select a specific child number for that SQL. So that means we can actually see the execution plans for multiple child cursors. And with SQL Developer, we have the option to see the explain plan, which we don't want to, but we can see the execution plan, which is good. SQL Developer shows you the execution plan this way, which in my opinion is a little bit hard to read, but once you get used to it, you're fine.
Is that an execution plan or explain plan?
In this case, it is an execution plan because I selected a specific child cursor. Yeah, well, you can also see the explain plan. Just be aware that you have either one or the other. Then we have this DBMS X plan. So what is the plan with DBMS X plan? Well, we have multiple APIs inside this package. The first one says display, which is basically just reading from the plan table. How do we populate into the plan table? With explain plan 4 command. When you execute the explain plan 4 command, basically you populate some information on the plan table. And with this API, you can list that. That's basically the way it works. We have this API in bold, which says display cursor. That is the one that you use every day. Then we can display from AWR. This one, unfortunately, this one is kind of incomplete. It doesn't give you a lot of detail, a lot of information, okay? For example, we don't get to store on AWR predicates. We don't get to see the predicate information. But we get to see, most of it. Then we have display SQL plan baseline. Who uses SQL plan baselines here? Some hands. Okay, I would like to see more hands next time. Yeah, SQL sets. We can show an execution plan out of a SQL set. Who uses SQL sets? SQL sets are very, very useful. For example, if you're going to migrate an environment, you may capture a SQL set on the environment, which basically is going to capture the execution plan inside the SQL set. Then you can migrate the SQL set, and from the SQL set, you can create a baseline. Is that clear? So it's like a method. So instead of creating the baselines and migrating the baseline, you can create the SQL set, you don't change the environment, move the SQL set, and create baselines out of the SQL set. So those are some tricks. We can talk more about those later at some point. And then we can select from this API, select start from table, pass the name of the API with some values here. For this one, display cursor, we pass the SQL ID, we pass the child number. If you don't pass anything, it defaults to child number 0. And that is tricky because sometimes you execute the SQL a couple of times, you have more than one child cursor, and you try to display the plan, and you are just stuck displaying 0 because you're not specifying which child cursor. Format, which is the third parameter. It takes multiple values, typically the default, but then if you say all includes typical, plus query blocks, plus column projections, plus table aliases, plus remote information. And if you say advanced, advanced includes all, plus the outline, plus binds. And to me, these two are really important. The outline and the values of the bind variables when the SQL was parsed. Is that clear? So I suggest you use this more often because you get the best. Then when you say all stats, you get these two for all the executions. But if you only care about the last execution, you say all stats last. So you can even say advanced all stats last, and that works fine. For 12C, there is another value that is called adaptive. So this is a sample with a query. We notice this query has some binds. It has a bind here, right? And it should have another bind on date, someplace here. Then we define those binds, define and assign values, and we have some hints. I mean, we basically name the query block, and we say gather plan statistics, monitor. Are you guys familiar with these two hints? Yes, no? Yes, no? Okay, this one basically allows us to capture during the execution of the SQL the actual number of rows per step of the execution plan. So we can actually evaluate estimated rows and actual rows. For SQL Tuning, this is really important. So you know if the CEO is making a mistake. So when you are diagnosing, you can use gather plan statistics to collect that extra piece of info. And monitor basically forces the use of SQL monitor. If we don't use the monitor hint, we only create a monitor information if the SQL takes more than 5 seconds. Okay? So with those hints are basically for diagnosis. Here is the output of the display cursor. Now we notice, for example, here, we see the estimated number of rows, and we have the actual number of rows. And that is very important. This one is given by the optimizer when the SQL is parsed. And this one is created at the execution time, so that is real. Now when you compare these two columns, now you can find if the CBO created a good plan or reasonable plan or not. Is that clear?
Yes.
Then we can see the binds, we can see the outline, we can see the query blocks. The outline is very important because let's say you are in a situation in which you have the same SQL in two different environments, and in one of the environments performs fine, and in the other one is not. So you can take the outline, which is basically a collection of hints, put it on the SQL, and run it on the other environment, and you get the same plan that you have on the first environment. That's an easy way to basically force on an environment a particular plan. Is that clear? So it's good to get the outline. SQL Monitor has been around since Oracle 10. It's part of the Oracle Tuning pack. And we can see all the information in two ways, as a table and also graphical. We see the timeline per execution line on the execution plan, so we can see where it started, where it completed. We can see binds for the parsing. We can see predicates. It's nice, and I would say it's easy to read. I mean, you look at SQL Monitor report, it's easy to read. And you can execute SQL Monitor either from OEM or directly from SQL Plus. You don't have to have OEM to use SQL Monitor report. This is a sample of the SQL Monitor report. We see the execution plan lines. We see the estimated number of rows. We see the actual number of rows. These two columns are important together. Cost is not that important, and we have some extra information like memory use, right? So we have a lot of information. We're checking if we're doing fine on time. SQL Monitor report can show you the execution plan this way, which is like an inverse tree, which is, to me is easy to read this way. Now let's talk about specialized tools. I mean, we talked before about all the product-based tools. Now, when I say specialized tools, are which tools they give you the extra kick, give you the extra information for your SQL Tuning analysis. The first one that comes in mind is SQL T Explain, also known as SQL T. You find this tool on the Majorco support under this note. It's free, as long as you have a Majorco support account, you can download the tool, you can use it. You have SQL Health Check, which is like a small version of this one. And then you have SQL D360, written by Mauro Pagano. Okay? So I would say today, if I need to use a specialized tool, I would use one of these three. From the three, I'm more inclined to use this one here, because this one gives me as much or almost as much as this one here, but this one installs nothing on the database, which is a main difference. This one requires to install a couple of schemas, and this one requires to install nothing. So I would use this one instead. There may be some others, yes, there may be some others, but these are the three that come to mind. Now regarding root cause analysis. Root cause analysis is the actual effort of doing the SQL tuning. There is no easy way here. It requires time. This is where you want to spend your time. So basically the way to go here is go to the output of these specialized tools and invest some time understanding everything that you see. Try to find correlations and possible what caused that correlation. Try to understand the CBO. If you do not understand the CBO, you may want to read more about how the CBO works internally. There is at least one good book on the CBO, so there is a lot of information about the CBO. Question everything. It's like, okay, this one looks weird. Question, investigate. I also encourage people to ask for help. The only thing that I ask for, when someone comes to me for help, I only ask this part. Do first your homework. Do some work. Show me your work. Show me that you have done something, and then come to me, okay? Or come to anyone that you wanna, you feel comfortable coming to. Ask for help. And enjoy it. If you like SQL Tuning, just enjoy that. Typical steps of SQL Tuning. First one is to find where the time is actually spent. People may say, oh, I have this execution plan with 300 lines. It doesn't matter, just find where the time is spent. Validate, in this case, estimate a number of rows, an actual number of rows. In other words, check if the CBO is making a mistake or not. Look at the history of this SQL. Did it ever work? Was it working fine? Did I make a change on the environment? And this one, you need to be able to understand both the SQL statement and the execution plan, and it requires time. Regarding remediation, you want to explore multiple options for remediation. Usually there is more than one way to fix an issue. Try to implement the one that affects the smallest piece. Don't go with a big change of the entire system if you can fix it by changing the SQL only, right? So you don't want to make big changes, you want to make small changes. Avoid this piñata method. So I don't know who knows what is a piñata. You guys know what is a piñata, right? This reminds me, sometimes you see people that they go like blind and they start changing stuff just expecting a positive change. It happens. I think everyone has done that. Okay? Just try to avoid that. And another one, trust no one. Trust no one, not even yourself. Be skeptic, and you have to test. Even if you say, oh, I have seen something that is, it's pretty sure it's the same. Not necessarily. Okay, just be aware of that. 3 important topics before we finish. We have like 5 minutes. The execution plan, the cost-based optimizer, plan stability. Those 3 areas are quite long, but I want to put one slide for each. Execution plan. This is very important. If you do not understand the SQL or you do not understand the execution plan, stop there. Just put the brakes. You have to understand it. Don't continue. Just stay there until you understand it. For SQL text, you may use some sort of diagram where basically each table is an entity and the predicates are the connectors between the entity. I used that in the past and it was pretty good. When you want to understand the execution plan, you want to start small. Start with 2 tables, look at execution plan, then do it with 3 tables, little by little until you feel comfortable. What about the CBO? Well, the CBO was released long time ago, almost 20 years, I would say. It's really complex, and it has had a lot of enhancements, so it's a big product, a big tool. By design, it's going to produce an execution plan based on the statistics and the state of data. So that means execution plans are going to change. They are expected to change. The CBO is designed to change the execution plan. We don't like it, but it's designed that way. Regarding plan stability, most DBAs, I mean, if you are DBA, we hate this. We change when the execution plan changes, right? Why? Because usually we get to know when it changed for the worse, not for the better. Because if the execution plan changed for the better, so far I've never seen a case where a user comes and say, okay, thank you, you helped me, the execution plan changed for the better. You never get that. But you get to hear the other ones when the performance regress, right? So how do we remediate that? There are several techniques, several things. I mean, we can use what? SQL plan management is one of them, right? What else? SQL profiles, right? What else? Outlines. What happened, Rodrigo? Which Pokemon? I don't see any Pokemon. And we can use store outlines on 99. I'm checking if there's a Pokemon there. And we can use SQL patch also, right? So there are several ways to enforce or to use plan stability. If you are on 11G, you want to use SQL plan management. On 10G, well, SQL profiles, 99, you don't have an option, store outlines. Who uses SQL patches? No one. That's an area you want to explore. They are very powerful. They're very useful. SQL patches. Maybe I should do a session on SQL patches. Okay, so free tools. Who likes free? Everyone likes free, right? Starting with the free coffee that we have here. We like free. So SQL TSPlane is free, SQL Health Check is free, SQL D360 is free, and there are a lot of standalone scripts which are also free. So use whatever you feel more comfortable. SQL TSPlane, that is the main page of SQL TSPlane. This is the main page for SQL D360. There is a lot of content here. That's another page from SQL D360 where we can see a lot of information for one execution plan. This is how we can see the execution plan on SQL D360. For example, in this case, in red, it shows me where the time is being spent, which is very useful because now I can focus here on this area. This is another report from SQL D360 where I can see histograms, which I can easily visualize them and understand them. This is another one where the same SQL generates 3 different execution plans, and over time, I get one plan, which is one here, or I may get this plan here, or I may get the blue one. So which one of these 3 plans is better?
The blue one.
The blue one, that's the one that we want, right? Well, we can easily visualize that information using SQL D360. If I were to compare these two, there are some pros and cons. SQL TSPlane is what Oracle is, what I developed SQL TSPlane, but besides that, SQL TSPlane is the one that Oracle supports, is the standard for Oracle. It's free, requires my Oracle support account. It's comprehensive and mature, having been around for quite some time. Cons, requires installation. That is the con. It requires to install something. And it has some HTML tables with no charts. What about SQL D360? Cons, it's also free. Installs nothing on the database. I think this one by itself is enough to use this one instead of this one here. And then we can see that the data is graphical, so we can see charts instead of just looking at plain HTML tables. Cons, yes, there are some cons. Still young. So what does it mean? Frequent releases. You get it now, you get it next month, and you may notice some things have changed, which is good. But if you're getting to familiarize yourself with the tool, you may notice some changes. So if I were to do a roadmap for SQL Tuning, I would start with a clean environment. Second step is find your SQL, then collect diagnostics, spend time doing the analysis, determine the root cause after spending a lot of time here, and then explore actions, more than one. Then test and implement the solution. So very quickly, do we have questions? No questions, so let me just finish here at the end. You can find here some downloads. You can download some of these tools are here. The pointers are here. Or you can email me for any questions, follow-up, whatever. Questions, I mean, or follow-up. And just keep in mind, I mean, SQL tuning, it takes some time, and it's a matter. So what happened? I don't see anything. Okay, so you have to see beyond what your eyes see first. I mean, there may be something hidden, like a Pokemon or something, right? So that's how SQL tuning works. Well, thank you for coming.